In order to learn how to create a linked list, first requirement is self-referential structure. You need to know self-referential structure. You have to create a self-referential structure. Okay. Suppose I want to create a student list. I can go for array. In array, I can even create a list of integers, list of characters. Okay. But in linked list, you can't create a list of integers just like that. A node cannot be just integer because a node needs multiple parts here. Node in a linked list requires minimum 2 parts. Right? Minimum 2 parts are required because one needs to be address part, another minimum one data element. You can have multiple data elements. ID number, name, like that. Okay. Even if you want to just have one ID number, that is integer. With only integer data type, you can't create this because in integer you don't have any address part. Integer means only integer. You can create integer array, but integer linked list you can't create using the integer data type. What you need? This data type should be a structure because it requires 2 parts. Multiple parts in single data type is possible only if you have structures. All other data types are one part only, right? All primitive data types, if you take, all primitive data types take only that part only. There won't be another part. But when you go for structure only, you can have in single thing 2 parts or more parts. Remember or not? Understood? Right? So you need to create a linked list only using structures. Even if you want to create just integer structure, you need to have a structure. Even if you want to just create a list of integers, linked list of integers, even if you want to create, you first have to create a structure with the integer part and address part. Okay. So usually you won't go for that. Let's take our student example only because we are going with structures. Let's take our student list of students I want to create. So suppose this is the institute. First one student joined. I will create one node. After a few days, second student took admission. I will add that to the second same list. I will add the second node. Like that, you can assume whenever a student comes for admission, then only I am going to create the node. Like that. Okay. So for that, I need a list of students. First, I need a structure. Student structure I need. Okay. So this is your struct student, in which I will have ID number, I will have name and other members also. You can have any number of members. Okay, name. Then I need this is all data part. I will have a pointer part. I must need a pointer part also here. So one pointer part is required, which will remember the next node address. So I must call it next. Any name you can take. I will call it next because every pointer member is remembering the next node address. So I will call it next pointer. So this is going to remember this node's address. This node's address like this. So this is a student. This is also student. This is also student. Then what is this pointer type? How should I declare it? Tell me.
Student.
That is also student only. Student pointer. Because it has to remember the next student address. So this must be a student pointer. Right? So this is already student structure. Inside that I need to create a pointer of the same student type. So I have to create it like struct student. Okay. So till now, whatever structures we have seen pointer members with other data types. Character pointer, integer pointer. But first time we are seeing a structure with a member as a pointer to its own data type. Right? The same data, while creating the data type, I am also using the data type inside the same structure. Right? So this kind of structure is called a self-referential structure. A structure with a pointer member of its own data type is called a self-referential structure. Because in a list, you have to remember the next node address in a pointer member, and the next node is of the same data type as the structure itself. Right? So you have to have a student structure inside a student pointer. This type of structure with its own type of data type pointer is called a self-referential structure. And if you want to create a linked list, you have to first create a self-referential structure. That is the first step. Without this, you can't create a linked list. Without structures, no linked list. In structures also, a special kind of structure, self-referential structure only you have to create a linked list. Okay, so here if you have a type ref, an alias name, when you are creating a self-referential link inside a structure, this alias name you can't use, because alias name is being declared after the member. It is outside. So this name you can't use here before creation. You have to still use this structure and template only. So you have to use struct student. This name only you can use. After creation of this line, you can go on using the alias name. Alias name you cannot use inside the structure. Okay, and you cannot create a member without the pointer of the same data type. You can't create just as a member. You must create a pointer only. The same data type, if you want to use inside the structure, you can use it only as a pointer, not as a member. Why? Because whenever a member is created, compiler should know what is the size that is going to add to the structure. It is going to add 4 bytes to the structure, 10 bytes to the structure. How many bytes here? If it needs how many bytes here, it needs to know the entire structure size. Then only it can decide how many bytes here. But the entire structure is not yet created. You are still here only. If you pass this line, go to the next line, then only you can decide what is the size of the entire structure. But here only you have to tell how many bytes. Then only you can go to the next step. So it's a deadlock. You can't go next. Without going next, you can't tell size. You can't go next. That is the problem. So you cannot have a same member as the data type itself. But you can have a pointer, because pointer size is always same. Right, here you know already it is just a pointer. What kind of pointer does not matter for size. Any kind of pointer, same size. Right. So here simply add 8 bytes. Add some more bytes. Like that, by the time it comes to the end, it will know what is the structure size. Then only the structure will compile. Compiler should know what is the size of the structure by the end of the structure definition. Then only this will go ahead as a data type. Right. So here the member should not be of the same data type. It can be a pointer to the data type. Clear? So self-referential structure is same data type of pointer member if you have in the same structure. Then it is a self-referential structure. And the self-referential structure is must to create a linked list. Because every node must remember the next node address. So assume that this is created already. We have created this kind of structure. Okay, second step. Head pointer. You need a pointer. You need some pointers actually. It's not just one pointer that you require. Minimum 2-3 pointers you will require. But the head pointer is the leader here. Head pointer is the main thing. Without this head pointer, linked list program won't work. Okay. So if you are creating nodes, second node, third node, you can create any number of nodes. But the main thing for this entire linked list is the head pointer. Head pointer means what? Head node address. This is the head node. But this head node address you have to store somewhere in a pointer. This is your head pointer. This is head node. This head node address you have to store in a pointer first. And this pointer is like your precious diamond. You have to keep it very safe. If you lose this pointers data, you will lose this entire list. Okay, you have to keep it very safe. You should not overwrite it. You should not assign anything to it. Unless you are changing the head itself, leader is changing, then only the pointer will change. Otherwise, it has to keep on pointing to this list always. No, not really required to be constant pointer, because you can change this head also. If you want to insert something here, you want to delete this node and create another node. Okay, you can keep it as a constant pointer, but when you are sure that this leader won't change, then you can make it a constant pointer. Okay, so this head pointer is very, very important. What kind of pointer will it be?
Voice pointer.
Student. It will also be student pointer, because head is student. Class leader, student. Next is student. This is also student, because it is going to remember head address. Head is a student, so it is a student pointer. Okay. So if you are creating a list of students, everything will be student pointers in your linked list program. List of employees, everything will be employee pointers. Okay. So you need a head pointer of the same data type as your self-referential structure. These two are minimum requirements. You will need more pointers. As a temporary usage, you will need more pointers. Okay. So the creation process is, first you will create one node. The first node you will create. How to create this one node? Dynamically, you will allocate memory. For this structure, you will allocate dynamically. How to allocate memory dynamically? I have told you, right? You will require malloc of size of student structure. This much amount of memory you need to allocate. This is student. This much amount of memory you need to allocate. Whatever address comes, that is your some temporary pointer you need to take. New pointer you will take. What kind of pointer will it be? Same, student only. Okay, never go directly for integer pointer. There is some common mistake done by everyone. That is why I am telling so much. Okay, usually the main data type everyone will take is integer. Because even in class I use integer more commonly. But when it comes to linked list, don't go on creating integer pointers. Because it is structure. Only structure pointers you have to create now. So student pointer you will need. This much amount of memory is allocated now. Now this you have to store in a head pointer. Whenever you need a new node, you will create and store in a temporary pointer. But only the first node you will store in the head pointer. So you will have a head pointer here, which will store the first node address. Okay. So when do you understand that this is the first node? Because maybe you are creating every node in a loop, or one after the other you are creating. Only first node you have to remember that you are going to put, this is the first node, so I am going to put it here as a head node. So the condition for identifying that this is the first node is that head pointer already does not have any address, then it is first node. Head pointer already has some address means already head pointer is filled. Head node is already there. You should not fill it. Right? So that kind of condition if you have to write, the already existing data should not be garbage. Only if it is null, then only you can identify that it is already not filled. Okay. So in linked list creation or any kind of program related to linked list, any pointer that you create, you have to immediately initialize to 0, so that this kind of conditions will work. No wild pointer should be there in your program. Every pointer that you declare, immediately initialize to 0. For safety, that will be very safe for you. If you don't initialize to 0, somewhere something will definitely break. Okay. So remember these points. Initialize, whether required or not, initialize all pointers to 0. 0 means null. All pointers immediately initialize to null. just to avoid problems, whenever you create any pointer in linked list, normal program also, even if you don't declare, it's okay. Even if you don't make it null, fine. But in linked list, it is mandatory. Whatever is the pointer, immediately initialize to null. Then 50% of problems are gone if you do this. Got it or not? Fine. So whenever you create a linked list, first node address you will keep in the head node. Right? When you create the next node, this is next node. This is again the new pointer. Whenever you create some memory, you will store it in the new pointer. Then this node address won't come here because it is already filled. You have already kept this node address here. Now next time onwards, you are not going to touch this because this is not null now. When it is null, then only you will keep the address. Next time onwards, it is no longer null. You are not going to touch the head pointer anymore. Okay. Then this new node address needs to be filled here. Okay, this pointer you have already noted, I hope. Okay. So this new node address you have to fill in the before node, right? So this pointers also you have to keep null only. Remember, every pointer should be null. When created, every pointer should be null only. Even this member pointer also should be null. Then only any condition will work if it is null. On heap, everything is garbage actually. So usually you will see lot of garbage values if you don't initialize to null. In normal programming also we don't see. If you create a pointer, by default it's 0 only. But on heap it won't be like that. You will see lot of garbage values. That is why it is always better to manually put a 0 in every pointer that is created. So when you create a node also, in the node, this pointer number must be manually initialized to 0. Explicitly you have to initialize to 0. Right? This new node is created. When created, its next member also should be 0. Right? Then this next member's address you have to keep here. Right? You will find out what is if it is the head node, you already have the address. If it is not the head node, somewhere here, the process will always be same. Okay? Suppose this new node you have created. This is pointing to null. This is pointing to null. Suppose I have to insert this here. Then you need to first find out what is this node. You have to start with head. Take head pointer, go to this node, go to this node, go to this node. Understand that it is the last node. Then this last node, next member, you will keep this address. It is the same process everywhere. Whenever you want to insert a new node at the end, whenever you want to add a new node at the end, you will first find out what is the existing last node. Its next member you will keep as the new node. Then this link will form. Again, one more new node you have to create. Again, find out what is the last node. Start from the head. Go. Find out this is the last node. Its next member you will link. This is the process you have to go on if you want to create a linked list with a new item adding at the end always. Okay. So if you want to write a first linked list creation with so and so elements I want to create, 5 elements I want to create. When I know that I have to create 5 elements, I don't have to every time start with head and go till the last node and then link. I can simply remember that this is the last node. This node address I can remember. When new node is created, then simply this last node and that new node I can link. Then I can make that as the last node. I will have one extra pointer as a temporary usage. For linked list, the main thing is always head only, but we can keep extra pointers for our programming use. Okay. So whenever you create a new node and add at the end, you will remember that this is the last node. So you will store this address somewhere in a pointer, in extra pointer, so that when a new node comes, directly you can link. Got it? So this extra thing we are going to have in our program, because we are going to write just creation part. Okay, so we'll assume self-referential structure is already created. Okay, so creation function, linked list creation. I'm going to assume that the linked list will be created as long as the user chooses yes. Whenever user chooses no, the linked list creation will be stopped. That kind of program we are going to write, menu driven. Okay, you can simply ask it, do you want to create next node? User says yes, create the next node. That kind of loop based program we are going to write, right? For that, I need to first create a head pointer. Head pointer is required, right? Head, whenever you want to create the linked list, first thing you have to create is head pointer, initialize it to null. Any extra pointers you can create. One temporary pointer I am going to create to hold the address returned by malloc. That also I am assigning to null. One pointer to remember the last node address. That also I am going to initialize to null. 3 pointers I am creating. All 3 pointers belong to same data type. Student, H, N, L. H is to remember always the head node. Initialize to null. New pointer. Whenever a new node is created, the new node address returned by malloc will be held in this pointer. It is also initialized to null. After creation of a linked list, the last node address is always remembered here. Null. These two, this is not mandatory always. In this creation program, we are going to have it so that we don't have to every time go to head and come back. Okay, this is just for ease of programming. We are going to have one extra point, but this is mandatory everywhere, right? Now we are going to take a choice from the user. Or while ch is not equal to n, keep on doing it. As long as user says yes, keep on creating a new node. So creating a new node, I am going to write a function for creation of a node, because this we are going to use in other operations also. Whenever you have to insert, you have to create a new node. So create node, I am writing as a separate function. It does not take any input. It will just create a node and return the address to you. That address I am storing in the null pointer. New pointer, sorry. The address returned by create node function will be stored here. Okay. So this create node function, what does it do? It will allocate memory, malloc of size of student. This much amount of memory it is going to allocate. Okay. So to store that, I need another pointer here, the same kind of pointer. It is allocating size of student. This much amount of memory it has allocated. The address I am storing in the pointer n. Right? This pointer I will return there. Here only I can fill the data also, if you want. Okay. So student ID number, student name I can read. Scan. What is student ID number? N is the pointer. How to get the ID?
N arrow ID.
Arrow. I need ID member of the student. Since it is integer, I have to give ampersand. Scanf, no? Then N arrow name. Only ID and name I am taking. Okay. There is a next member that I have to fill. Next member, immediately I need to fill. Even if you take this data or not, next member must be filled with null. This is mandatory. Whenever you create a new node, allocation of memory, then fill the next pointer to null. These two things are mandatory. This data filling you can do anywhere. After coming here or after creating the entire linked list, that is up to you. But this is mandatory to fill the pointer. Any pointers if you have, make them null. Don't leave them as wild pointers. Okay. So n next is next member. In the structure I have 3 members. Integer ID, character array, name, and then one next pointer I have for self-referential purpose. So that next pointer I am making it null. so that this new node that is created has no next pointer. It is not pointing anywhere. It is the just pure node only I have. So whenever I call that function, one new node is created. One new node is created. Just one node with next number null and then the ID number, whatever user enters. Suppose ID number is entered as 1. Suppose name is also entered A. This is the new node that is created. And I have to return this here. Right? So return M. This pointer after creation I am returning. Okay. What should be the return type of this function? Student pointer. Same kind of pointer I am returning, right? It should be student pointer. I am returning n. N is student pointer. So I have to write student pointer as the return type. So n value I am returning. So that n I am taking into this n. Okay. So here this is n pointer. This is head pointer. Both are zeros as of now. This is L pointer. That is also 0. Okay. 3 pointers I have. This is the new node that is created. Suppose address is 1000. This address is returned. So n value will be now 1000. After this step. N value is now 1000. Right. Now this is my first node. I need to store this address in head pointer. Okay, I should not put every new node address here because this is going to be a loop. After every creation, I should not put it in head. I have to check if it is already 0, then only I have to put this address. If it is not 0, I should not put because only first node address I have to keep here. Right? So since I have already initialized it to null, that condition will work now. Okay, so if head is null, then only make head is equal to new. So that this 1000 is copied here now. That means now head is pointing to this node. Your linked list is successfully created as of now. This is your linked list with one node. Head is storing the first node address. First node is the last node. It has no next node to point. Fine. Then when you are going for the next iteration, next iteration means what? Next creation, next node when you want to create. Before that you want to remember the last node address in L. Now this is the last node. So this node address you have to keep in L. Right? So I want to keep, before the loop ends, I want to keep N in L. So that whatever is the new node that is created, that is the last node. Right? So that address I am copying to L so that for the next iteration I have the last node ready with the previous node address. Previously created node address I will have in L. Getting or not? Before going for the next iteration I am going to do that. Means I will copy 1000 here before going for the next iteration. Right? So in next iteration I am going to create one more new node. Again, next iteration means you have to take choice, yes or no, all that you can write, right? So yes or no you will take. If the user says yes, then go create one more node. So what is that one more node? Again, create node with some data and the next node null. This next node null is always there. Whenever you create a new node, it will always be created with next node null. And the address is suppose 2000. And it is going to return that address. So n value is 2000. Now you are checking h is equal to null. That is false. Right? H is null is false. Means this is no longer the first node. This is the second node. So second node onwards, what you have to do? You have to connect the second node onwards to first node, before node. For first node, you don't have to do anything. First node just storing it in head only. From second node onwards, you have to link to the previous node. And previous node is in L. When you have created the second node, L is pointing to the first node. Right? Means you have to link this and this. That you will do through L, not through H. H you should not touch now. You will link L in this. How you are going to do that? In else part, because this is not the first node. For first node only you are going to fill head. From second node onwards you have to do something else. What is that something else? You have to link this and this through L pointer. How you are going to do? Through L, I will access this number and then fill this address here. Did you get it or not? Okay, and this address is in M. Right? So L next member is equal to M. Okay, means I am going to write N here 2000. So that this is now going to be linked like this. Okay, so what I am going to do in else, L next member is equal to N. Okay, if you understand, this is the simplest code in entire C. Linked list creation is the simplest program only if you understand it. What is going on in each step, if you understand, simplest program. Done, linked list is done, creation. Okay. Okay, now let's see another node creation. So here what I have done, L next, I have access of this number through this pointer, and here I have written this address. So that this link node is now connected to this link next node. Okay, this step is done. Now the next step is L is equal to N. L is equal to N means now the new last node is this one. So this address I am writing here. Now L is this. This is the last node. Now linked list is starting from A, next node is B, and this is the last node. Now head is pointing to the first node, L is pointing to the last node. After the second iteration, L is pointing to the last node. Go to the third iteration. Third iteration, create node again. Create a new node. Take ID number, name, fill next node, null. Address is 3000. Okay, return 3000. So N value is 3000 now. Okay, so this new point is pointing to this node. Then if H is equal to null, no. Go to else case. So what is L? 2000. This is the last node, right? L next is this number. Fill this number with N value. N value is 3000. So write 3000 here. This is no longer null. This is 3000. Means this node is connected to this 3000 address node. Next, L is equal to N. Means L value will be now 3000. Means L is now this node. Okay. After the third iteration, the linked list has 3 nodes. First node is pointed by head. Last node pointed by L. Middle node we don't have to remember. Okay. Again, next iteration. Create new node. Create another node. This is the data. Next member is null. Whenever a new node is created, next member is null by default. Okay. Then head is equal to null is false. Go to else case. Else case. This is address 4000. New is 4000. Create node has returned 4000. N value is 4000. This is false. Go to next. Now L is pointing to 3000 address. L next is this number. Write new value here. M is assigned to L next. So write 4000 here. That means this is connected to this node. Okay. Now L is equal to N. L value copy N. Means this is now pointing here. Okay. So as you go on doing this, more iterations, more nodes, you will have always head node stored in the H pointer, last node stored in the L pointer. You can anytime add a new node. Is this clear, everyone? This is creation only. Okay. There will be main. From main, I will call creation. No? So after creation of the entire linked list, I have to return head. This head is required in main. Okay.